Problem set 3.6. We're going to go through a few practice problems here for you. So if you want to follow me on page 219 as we go over some of these. First of all, let's look at 1 through 12, changing mixed numbers to improper fractions. So we have, let's look at number 10, 5 and 18 over 19. That one is not going to be a pleasant one, but the method is still the same. 5 times 19 plus 18, and then that answer will be over 19. So we know 19 is going to be in our denominator position. We just have to find out what to put in the numerator. So we multiply 19 times 5, then we add 18 to it, and we get 113 over 19. So that's all there is to changing mixed numbers to improper fractions. Let's look at, well, I guess it really doesn't make any difference. 1 and 6 over 7. Everything is done the same. I know my denominator is 7. Now I have to find the numerator. 1 times 7 plus 6 is going to be what I need to do to get my numerator here. 1 times 7 is 7 plus 6 is 13. So I get 13 over 7. Alright, that brings me to 13 to 24 on page 219. Changing improper fractions to a mixed number. So look at 14. It has 10 over 9. You remember the 10 goes inside the division box. The 9 outside. 9 goes into 10 one time. 1 times 9 is 9. We have 1 left over. Remember, whatever our remainder is goes in the numerator, and this number goes in the denominator. Okay, so 1 and 1 9. Alright, let's do one more. Let's do 319 over 23. Alright, so again, my 319, my 23, you know what you could do? You could just put your fraction up here for your remainder and put a 23 here, because you know that it's going to be 23. It's always going to be that. So now we just have to find out how many times 23 goes into this, and the remainder then will just go here on the top. So 23 goes into 31 once. 23, 1 times 23 is 23. 11 minus 3 is 8. And bring down our 9. This probably goes into, let's see, 4 times. 4 times 3 is 12. Nope, 3 times. So we'll put a 3 there. 3 times 3 is 9. 3 times 2 is 6. Leaving me with 20. Okay, so what my answer ends up being for that is 13 and 20 over 23. Notice I stopped when I got to the last number. That's how I determined that I had a remainder, is when I brought this 9 down, whatever I get after I bring this last number down, that bottom number here is going to be my remainder. And it will always be smaller than this. If it's not smaller than this, you did something wrong. You need to go back and sort through here. So this number will always be a smaller number than the 23. Alright. Which brings us to some problems like down at the bottom of 219, numbers 25 to 36. We did some similar to 25 through 30. Trying to see if there's any in here. Let's try 33. 5 plus 3 over 2x. Okay, same rules apply, same questions are going to be asked. We're going to make that 5 over 1. Again, I have a variable in my denominator, so that's when I ask the question. What am I missing here that I have here? I'm missing a 2 and an x. Also, if you remember, I said if you have a 1 in your denominator, it will mirror or become whatever this is. So, I've got a 1 there that will automatically turn into a 2x, but I need to remember to multiply that times 2x as well. So 2x times 5, remember we can multiply the numbers, not the variable. Just tack the variable on there. And 3 over 2x. And because our denominators are the same, we can combine everything. 10x plus 3 over 2x. Now remember, we cannot cancel the x's because this plus sign locks this whole thing together as one unit. It is not 10 and x and 3. It's 10x plus 3. So unless you have a 10x plus 3 in the denominator, you can't cancel anything out. Okay? You cannot reduce 10 over 2 to 5. You cannot cross out the x because of this plus sign. Very important to remember that, because students make mistakes on that all the time. They look at that and think, oh great, I can cancel that and be 5 and cancel my x's. Don't do that. There's a plus or a minus sign. That should stop you from going any further, or at least looking and seeing what's going on there. Alright, so that is problem set 3.6. We'll be ready for 3.7 in just a few.